For decades, the skies have been dominated by the engineering marvels of General Electric and Rolls-Royce. Their names are synonymous with power, reliability, and the undisputed technological edge of the West. But what if that dominance is about to be challenged? Not by an engine that's more powerful on paper, but by one that is profoundly more strategic. China has rolled out its new WS-20 engine, and it's giving Beijing 5 critical advantages that its Western rivals simply can't match. So, how is China outmaneuvering the titans of aerospace without necessarily winning the raw horsepower race? The answer reveals a tectonic shift in global power, where strategic independence is becoming the ultimate weapon. But the real reason this engine matters isn't obvious yet, and it's already changing how air power works. The jet engine is the heart of air power. It's the single most complex piece of technology on any modern aircraft, a crown jewel of industrial capability that only a handful of nations have truly mastered. For half a century, that exclusive club has been led by the US and the UK, with companies like General Electric, Pratt & Whitney, and Rolls-Royce setting the global standard. Their engines power everything from stealth fighters to the world's largest airliners. This dominance has been a powerful tool of Western influence. Nations that fly Western aircraft are tied to a Western supply chain for parts, maintenance, and upgrades. For China, this technological dependency was a major vulnerability in its ambition to become a world-class military power. From its earliest fighters to its first strategic airlifters, Beijing relied on imported and often second-rate Russian engines. This throttled the performance of its aircraft and put a hard limit on its strategic freedom. But that era is over. The introduction and mass production of the Shenyang WS-20 high-bypass turbofan engine is more than a technical achievement. It's a geopolitical event. By successfully fielding this engine, China isn't just catching up. It's executing a brilliant strategic maneuver. It's playing a different game, where self-sufficiency, production scale, and platform integration create advantages that raw thrust numbers can't beat. While GE and Rolls-Royce may still build more powerful engines, the WS-20 is allowing China to outrun them in 5 crucial ways that are reshaping the balance of power in the skies. The first and biggest advantage the WS-20 gives China is something money can't buy: total strategic independence. This isn't just about national pride. It's about unshackling its military from the geopolitical whims of other nations. For years, China's flagship strategic airlifter, the Xi'an Y-20, nicknamed Chubby Girl, had a glaring weakness. It had a massive, modern A-frame comparable to the American C-17, but it was powered by antiquated Russian Soloviev D-30 KP2 engines. These were inefficient, low-bypass engines from a previous generation. This meant that from the moment the first Y-20 rolled out in 2016, its potential was kneecapped by foreign technology. Relying on the D-30 was a strategic liability. First, it created a logistical headache. The Chinese Air Force was dependent on Russia for new engines, spare parts, and support. In any conflict, that supply chain could be threatened or cut, grounding China's heavy airlift fleet at the worst possible moment. This was a technological Achilles heel that Beijing was determined to fix. Second, the Russian engines were simply underpowered. They were a stopgap that kept the Y-20 from reaching its full potential. The aircraft was designed to carry a massive 66-ton payload, but the weaker D-30 engines often limited it to loads closer to 50 tons. It was like building a state-of-the-art cargo ship and then slapping on the engine from an old tugboat. You have the ship, but you can't unleash its true capability. The WS-20 changes all of this. It's a domestically designed high-bypass turbofan built specifically for the Y-20. Its service entry in March 2023 marked the moment China cut the cord. With the WS-20, China no longer needs to ask permission or rely on a foreign partner for the heart of its strategic airlift. It can produce as many engines as it needs, on its own schedule. Analysis from outlets like the War Zone suggests this development means the Y-20 can finally enter unlimited production. This stands in stark contrast to the position of many other nations, even those allied with the West. Countries operating American or European aircraft are still fundamentally dependent on that external industrial base. With the WS-20, China has achieved a level of self-reliance in the heavy lift sector that few others can claim. It's a declaration of technological sovereignty that frees China's military from a critical vulnerability. Next, the WS-20 outmaneuvers its rivals by finally unlocking the true capability of the aircraft it was built for. It transforms the Y-20 from a compromised platform into the strategic heavyweight it was always meant to be. As mentioned, the Russian D-30 engines were a significant bottleneck. With a thrust of around 26,450 pounds, they were just too weak for an A-frame designed for a maximum takeoff weight of 220 tons. The result was a frustrating performance gap. The Y-20 airframe was ready for heavy-duty work, but its engines weren't. The WS-20 engine solves this problem. Each WS-20 produces an estimated 31,000 pounds of thrust, a huge leap over its Russian predecessor. Multiplied across 4 engines, this extra power allows the Y-20 to finally achieve its maximum design payload of 66 tons. What does lifting an extra 10 to 15 tons per flight actually mean? It's the difference between transporting some of your armored vehicles and transporting your most powerful main battle tank. This opens up the very real possibility of airlifting China's most advanced armored vehicles, like the 55-ton Type 99A main battle tank, a feat that was previously out of reach. This capability dramatically changes the calculus for rapid deployment, allowing China to move its heaviest combat formations directly into a theater of operations. This puts the Y-20 in a special class. While the American C-17 Globemaster III can carry a heavier payload of around 77 tons, the C-17 production line was shut down for good in 2015. The United States isn't building anymore. China, on the other hand, is now positioned to mass-produce a fully capable strategic airlifter, making the Y-20 arguably the largest military transport aircraft currently in serial production anywhere in the world. By unleashing the Y-20's full potential, the WS-20 gives Beijing options it simply did not have before. Power alone was never China's real problem. Range was. Power and payload are only part of the equation. The other critical factor is range. The third way the WS-20 provides a strategic edge is through its modern design, which dramatically improves fuel efficiency and extends the reach of China's A-fleet. The old Russian D-30 engines were fuel guzzlers from a different era. As low-bypass turbofans, they were far less efficient than the high-bypass engines that power modern Western airlifters. In simple terms, the original Y-20 burned too much fuel, which limited its endurance and forced it to make refueling stops on long-haul missions. The WS-20 is a completely different animal. As a modern high-bypass engine, a much larger fan pushes a greater volume of air around the engine's core, generating thrust far more efficiently. The result is a major drop in fuel consumption and a big increase in range. Chinese military experts claim the WS-20 uses significantly less fuel, giving the Y-20 the ability to conduct intercontinental flights without needing to stop. With its full payload, estimates suggest the WS-20-powered Y-20 has a range of up to 4,800 miles, or 7,800 kilometers. This newfound efficiency is a game-changer, especially for the Y-20, the aerial tanker variant. An effective tanker needs to carry a lot of fuel and have the endurance to stay on station for long periods. The WS-20's high-bypass engines are perfect for this. Their fuel efficiency means the tanker itself burns less fuel, allowing it to offer more of its payload to other aircraft. This could potentially double the operational reach of China's fighter jets, like the J-20 stealth fighter. This efficiency allows the PLAF to project power far beyond China's coastline and deep into the Pacific. It's the key that unlocks China's ambition to create an A-force that can sustain operations far from home. GE and Rolls-Royce engines may be efficient, but they aren't enabling this specific, rapid expansion of a rival's strategic reach in the same way the WS-20 is for China. Even with a working engine, China still faced one major risk: speed. The fourth way China is outrunning the West isn't in the air, but on the factory floor. The speed at which the WS-20 went from concept to mass production is a sign of China's maturing industrial power and a warning to Western defense planners. Developing a modern jet engine is usually a long, difficult, and expensive process, often taking over a decade. It requires mastering exotic materials and incredibly precise manufacturing, an area where China has historically lagged. The WS-20, however, tells a different story. Reportedly deriving its core from the proven WS-10 Taihang fighter engine, Chinese engineers had a solid foundation to build upon. Testing of the WS-20 began on a testbed aircraft around 2014. By 2020, photos emerged of a Y-20 flying with the new engines, and by March 2023, the Y-20B, equipped with 4 WS-20s, was officially in service. Going from initial flight test to service entry in under a decade is an impressive sprint for such complex military technology. This rapid cycle contrasts with some of the more drawn-out procurement programs in the West. But the real strategic advantage isn't just development speed, it's the move to mass production. While Western nations might produce a handful of strategic airlifters per year at peak production, China's state-backed industrial model is built for scale. Now that the engine bottleneck is gone, China can ramp up production of the fully capable Y-20B at a rate that could quickly expand its fleet. While hurdles for advanced materials still exist, the main technological barriers for the WS-20 seem to have been cleared. This means China is on the verge of fielding a large, modern, and entirely homegrown strategic airlift fleet. The sheer number of available A-frames could become a decisive advantage in a prolonged conflict, enabling a massive logistical effort. The experience gained from the WS-20 also benefits other critical engine programs, like the WS-15 for the J-20 stealth fighter, creating a cycle of innovation. China isn't just building an engine, it's building an entire aerospace engine ecosystem. The fifth way the WS-20 punches above its weight is through the strategy it represents: versatility. This engine is a foundational piece of technology that Beijing is using to empower multiple critical platforms, creating a more standardized and capable fleet. The most obvious application is the entire Xi'an Y-20 family. This includes the Y-20B transport, the Y-20B aerial tanker, and a potential future airborne early warning and control (AEW&C) variant. By using the same core engine across this family of large aircraft, the Chinese Air Force can streamline its logistics, maintenance, and training. It's a classic strategy for building an efficient military, now being executed with homegrown technology. But this isn't happening in a vacuum. The WS-20 is the heavy lift specialist in a growing family of domestic Chinese engines designed to end foreign reliance. Other key aircraft are getting their own tailored upgrades. The H-6K bomber, for example, has been refitted with a more efficient, Russian-derived WS-18 engine, extending its range and performance. The overall strategy is clear: create a standardized, efficient, and all-Chinese powertrain ecosystem. The WS-20 is the solution for the heavy fleet, while other engines solve problems for fighters and bombers. While General Electric and Rolls-Royce build a vast portfolio of excellent engines for a diverse global market, China is leveraging its new engine family to systematically solve its own military's most pressing problems. This holistic approach creates economies of scale and simplifies logistics. It is a focused application of technology that gives China a strategic coherence that is, in its own way, outrunning the more market-driven approach of its Western competitors. The Shenyang WS-20 is not the most powerful jet engine in the world. It doesn't have the record-breaking thrust of a GE9X or the decades of proven reliability of a Rolls-Royce Trent. But judging it on raw power alone misses the point. This is why the WS-20 should concern Western defense planners more than any single thrust figure. It proved China no longer needs to beat the West engine for engine. It just needs to outproduce, out-integrate, and outscale. The WS-20 isn't about winning a spec sheet war. It's about winning a strategic competition. This engine has allowed China to achieve what was once thought to be decades away: true strategic independence in large aircraft propulsion. It has severed a critical reliance on foreign suppliers. It has unlocked the full potential of its Y-20 airlifter, turning it into a formidable tool for global power projection. Its modern design is expanding the reach of the entire Chinese Air Force, especially its vital tanker fleet. Perhaps most importantly, the WS-20 is being produced at a speed and scale that reflects China's industrial might, enabling a fleet that could find an advantage through sheer numbers. And the strategy behind it, creating a family of engines for a more integrated force, shows a clear and focused vision. The rise of the WS-20 is a story of smart strategy and a relentless drive for technological sovereignty. It proves you don't have to be the best in every single category to change the game. In the arena of independence, scale, and strategy, the WS-20 is already flying far ahead. What do you think is the most significant strategic advantage the WS-20 gives China? And what technological development should we cover next? Let us know in the comments below. Because the WS-20 solved one problem, but it exposed another China still hasn't fixed.